Example 6, we're trying to solve this equation right here. First thing you should notice is there's only one variable term. Okay? And so that's good. When there's only one variable term, we can isolate. That's what we want to do. That's going to be the easier one. Okay? But what you also should notice is that there's a half of an angle. Okay? X over 2, there's a half angle. And so what we're going to have to do is take this interval and take half of the interval. We're only really going to look from 0 to pi for the half angle. Okay? X goes from 0 to 2 pi, but x over 2, my half angle, is going from 0 to pi. Okay? So when we solve this, we're going to isolate just like always. And so the first step, I'm going to divide by this 2. I would have sine of the half angle equals 1/2. Okay? Now, I'm going to have people try to do something about that 2, and I'm going to have people try to multiply by 2 or something and cancel that out. You can't do that. Okay? You're not allowed to do that, so please don't try to do that. Solving the equation is like peeling an onion, and you have to get rid of the outside layers first. Okay? The next layer we're going to have to peel off is this sine. You can't touch this 2 until after you've gotten rid of this sine. Okay? So make sure the next step you're going to do is an inverse sine to get rid of that sine function. We're going to have x over 2 equal inverse sine of 1/2. I know I'm writing probably more than what I would normally write, but that's what we're going to have. We have to do the inverse sine of 1/2. And so, I wouldn't use a calculator here. I'd use the chart, but whatever, either way. Use the chart, inverse sine 1/2, and you're looking at that 30-degree angle, I know, but notice we're in radians, so you can't say 30. You'd say pi over 6. Okay, does everybody see a pi over 6 reference? It's a pi over 6 reference angle where sine numbers are positive. Okay, so pi over 6 where sine is positive. And so take a look at where sine is positive. You have pi over 6 where sine is positive. We know that's upstairs. And so we call this pi, no, wait a minute, with a common denominator, that's 6 pi over 6. Okay? And so the angle, pi over 6 before you get to 6 pi over 6 would be 5 pi over 6. And then this other one, you call this 2 pi, no, with a common denominator, that's 12 pi over 6. Oh, wait, no, I don't have to do that. What am I talking about? It's the first quadrant. So first quadrant, this is what it is. So we have pi over 6 and 5 pi over 6. Okay? But if you think about it, okay, and this doesn't really come into play here, but you have to think about the interval. Usually when there's like a doubled interval or a tripled interval or something like that, it's going to come into play more. But what this says is for the half angle, which is the level I'm still at, I've got x over 2, I've got my half angle. It says I'm only allowed to go from 0 to pi. In this case, and this doesn't happen very often, but in this case, that's exactly what I have. I've got angles going from 0 to pi right now. And so I don't really have to do anything more. Okay? I don't have to do anything more with that interval. I'm already all set up with my interval from 0 to pi. But what I have to do now, the last step, is to isolate x. And so, just think about if you had x over 2 equals 10, or anything, you multiply by 2 in order to isolate x. And that's exactly what we're going to do here. Okay? In order to isolate x, I'm going to multiply by 2. And so that cancels out the 2, and I get x equals 2 pi over 6 is going to be pi over 3. And this would be 10 pi over 6, or you can think about canceling this and 3. It's going to be 5 pi over 3. And so that's it. That's my answer. I just isolated x, and that was the original goal. Solving the equation, isolate x, you get pi over 3 and 5 pi. Part B says, then give all solutions. We're going to skip that for now. Maybe we'll come back to that later, but we're going to skip that. I want to go back into part A and just imagine what it would look like with a cosine. Okay, if that had been cosine instead of sine, if you had, at the point where we were inverse sine equals 1/2, if we had done inverse cosine of 1/2, okay, inverse cosine of 1/2 would have been a pi over 3 reference, where it's positive, but where cosine is positive is over here. And so I don't really care about the numbers all that much, but remember our interval was from 0 to pi. And from 0 to pi is going to exclude this angle right here. This one wouldn't count, and so we wouldn't count it. You'd only have one answer in that case. So you really, you'd really only count this one. That would be a pi over 3, and that would be your, x over 2 equals pi over 3. And so you multiply by 2, and x would equal 2 pi over 3. You'd only have one answer in that case, because the interval excludes that second angle. You really want to pay attention to that. Okay, you really want to pay attention to that, because it's going to be important. Really look at the interval. Don't ignore it. I know it's tempting to, but don't.